Let's start with the Zeroth Law of Thermodynamics. The Zeroth Law says that if object A is in thermal equilibrium with object B, and object B is in thermal equilibrium with object C, then object A is in thermal equilibrium with object C. This is essentially the transitive property of temperature. I'm sure that at some level this is a very profound law, but on the other hand, I'm not sure that it's a coincidence that it's called the Zeroth Law of Thermodynamics. It just doesn't blow my skirt up. How about the first law of thermodynamics? Well, the first law of thermodynamics is basically the law of conservation of energy. That energy morphs between its various forms, but the total amount remains the same. In physics, when we say energy, we really mean mass and energy together, but we're not going to go there right now. In thermodynamics, the first law is often expressed with this equation here. Delta E is equal to Q plus W, where E, you might remember, is the internal energy. Why does this demonstrate the law of conservation of energy? If it says that the internal energy could change, how does that imply that energy is conserved? This equation is for a particular system, you might say a particular object, and if that object has work done on it, or if it releases heat, what happens is the delta E of something else will then change accordingly. So work is put in, or work is done on something else, or heat is put in, or heat is taken away. But if you take the delta E's of this system, and then the one next to it, and the one next to it, and the one next to it, and the one next to it, the total amount of energy, while it might be transferred between systems, stays the same. That's why this equation demonstrates the law of conservation of energy, even though it looks like, hey, energy is changing. The second law of thermodynamics says that the total entropy of a system never decreases over time. In other words, the total amount of disorder, the total amount of chaos, is never going down. It's always either staying the same or it's increasing. In the rare instance that a system is isolated and is the site of a reversible process, then the change in entropy of the system is equal to zero. This is a comparatively rare case. In all other cases, the entropy of things is increasing. This is definitely the case for all spontaneous, that is, all irreversible processes. This just is a fundamental fact of the universe that the total amount of entropy is constantly on the rise. You can see we have a messy closet on the left and a more orderly closet on the right. You might say, well, it looks like the system's entropy has decreased. The chaos, the disorder has decreased. And that is most certainly true if you are considering just that closet. But it took work to do that. Somebody had to straighten all these things, throw things out, and in doing that, the room warmed up because energy was released in that process. And if we could somehow quantify all of those entropy changes, we would find that in total, while the closet entropy has decreased, the entropy of the room, and in fact the universe, has increased. Unlike energy, entropy is not conserved. It's constantly increasing. The third law of thermodynamics says that the entropy of a pure crystalline substance at absolute zero is zero. That would be a state of perfect order. And of course, this is an impossible mission. Changes in entropy can be negative, but the absolute entropy of something can never be zero and can never be negative. Let's summarize the laws of thermodynamics. The Zeroth Law says If two objects are each in thermal equilibrium with a third, then they are in thermal equilibrium with each other. That is, they're at the same temperature. Energy is conserved. In other words, the change in any system's internal energy, delta E, equals the work done on or by the system plus the heat flowing into or out of the system. The second law says the total entropy of a system never decreases over time. And the third, entropy, that is the disorder, of a pure crystalline solid at absolute zero is zero.